Hey, you're on YouTube now. Significant figures, also called significant digits. Actually, it's called sig figs for short, or if you're British, sig digs for short. What's the difference between $600 and $599.87 besides the obvious 13 cents? One value is more precise than the other. In fact, if I see that number there, I'll assume it's probably a rounded off. If somebody says it was about $600, as opposed to if somebody says it was about $599.87, I don't think the word about belongs there. I think exactly. One is more precise than the other. In science, we say one has more significant or relevant figures or digits than the other. Put your pencils down, look up. The rules in English for sig figs are complicated. It's much easier for me to do a whole bunch of examples with you, have you spot the pattern, and then we'll write the rules. So don't write this down. 8 has 1 sig fig. 12 has 2 sig figs. 4,382, anyone want to guess? 4 sig figs. So we start out like that. Now it's going to get weird. 30 has 1 sig fig, not 2. 300 has 1 sig fig, not 2, not 3, 1. 4,500, 2 sig figs. So zeros that come after digits that are what we call in math placeholders, we don't count those as significant. We say, okay, you measured that number, you measured the... Okay, let's get a cursor here, Mr. Dueck. Gonna get a cursor there? Okay. My app's not working quite the way I want it to be. Let's get back to green. Eraser off, ink on, green. I'm gonna have to stand up. You measured the 4, you measured the 5, and this is where you started saying about-ish, kind of. Keep going. Three sig figs. Zeros in the middle count. Okay, we do count those. 3 sig figs. Zeros in the middle we count, but zeros on the end we do not. How many sig figs? How many sig figs? How many sig figs? How many sig figs? What if I measured this and the number that I got right there was a 0, and I want to show that that's supposed to be 2 sig figs. It just happens to be, instead of an 8 or a 4 or a 1, there's a 0 there. I do this. I add a decimal that normally doesn't need to be there by putting that there. Courtney, I'm saying actually that 0 was measured, and it just happened to be a 0. So that is 2 sig figs. We had to come up with some way to show that, and we didn't want to have to write a whole paragraph. What about small decimal numbers? 1 sig fig. 1 sig fig. Guess? That's 2 sig figs because the 4 and the 1 are significant. 3 sig figs because zeros in the middle count. How many sig figs? How many sig figs? Still. How many sig figs? Still. What if I measured this and instead of an 8, it was actually a 0? I would write it, that is also 3 sig figs. So zeros that appear after a decimal point, after a number, we assume you measured them, because otherwise there would be no reason to put those there. The only reason you would have put those there is the ruler or the scale or whatever measuring device that you were using was that accurate. That's 3 sig figs. 1 sig fig, 2 sig figs, 3 sig figs, 4 sig figs, 5 sig figs. Kind of spotted the pattern. That's why I said it's easier to do a bunch of examples. We're going to write this out now, Kenley, in English, but the English part is going to be confusing. There's the pattern. Let's go to our notes. Pick your pencils up. First of all, 600 has how many, Courtney? 1. What if I wanted it to have 3? Well, then I would have, Kenzie, that would have 3. That's 1. Good yawn? I know, this is dry. You won't yawn during the physics stuff, trust me. How many sig figs does $599.87 have? Kenzie? Yes. So here are the rules if you want them as such. Any non-zero number counts. 456, how many sig figs?
3.
0.9723? Yeah. Zeros to the left of a decimal point count. Now, left for you folks is that way. So there is a decimal point in that first one. So a 0 to the left of it will count. Rowan? 3. What about the second one? Not 3? 2. And what you're really saying, Evan, is right here is where you started rounding off. The instrument that you were using to measure was only accurate to the tens place, where this person was using an instrument that was accurate to the ones place. It was more accurate. You okay? Good, leave him alone. He's a troublemaker. Zeros to the right of a decimal are trickier. If there are non-zero numbers to the left, they count. Otherwise, ignore them. So, how many sig figs? Not 2. 4. How many sig figs? 6. How many sig figs? 2. 3. And then the tricky one. 4. Otherwise, why would you have bothered putting those zeros there? You must have measured those last 2 zeros, and it just so happened that when you measured that number, the last 2 digits were zeros. So we've thought about how we can show this accuracy. It is well thought out, and it is a little tricky to wrap your brain around, but we'll get there. So, step 1, you've got to be able to count the number of sig figs, Savannah. You with me? Good? Okay, you're looking at something. Focus elsewhere. Here are the rules for rounding off in science. This is what you call rounding off in math, but we call it sig figs, and this is going to be how you do it in chemistry, in physics, and in biology. And you can get your calculators out. First thing, you never round off until the end. So all of you on your calculators, type that in exactly. 6.74 times 2.0002. Come on. 6.74 times 2.0002. And this is going to explain how I was doing that answer key that you were looking at the other day and wondering why I was rounding off to what I was rounding off. We don't write everything. Okay? Do you all have 13.481348 on your calculator? Some of you might have it in scientific notation. Some of you might. What? We got that? Okay. With your pencil, really lightly, how many sig figs is 6.74? Write a little tiny 3 above it. How many sig figs is 2.0002? Write a little tiny 5. See those 2 numbers that I wrote in red? What's the smallest number? We're going to round to 3 sig figs. That's how you do it for multiplying and dividing. You round to the smallest number of sig figs in your data. So how many sig figs are we going to round to? Say it again. How many sig figs are we going to round to?
3.
On your calculator then, and you guys just look up 1, 2. The 4 is sitting in the third sig fig. But now I ask, is the 4 going to stay a 4 or is it going to become a 5? Because of the 8? This would round off to 13.5, and that's how we round off in science. Multiplying or dividing, the rule is the same, and it's the easier one. Adding and subtracting is tougher. We'll do that in a second. So, 6.4, type it in as is. Don't round off beforehand. 6.4 divided by 9.088. 6.4, how many sig figs is that? In your notes right now, write a little 2 there so you know what you're doing. In the homework, you'll probably get good enough that you don't need to write those little numbers down. And if you do, great. But something that you're studying later, we'll do that. 9.088, how many sig figs? What's the smallest number that I just wrote? So I'm going to go to 2 sig figs. Okay. I'm going to stop at the 0. Is the 0 going to stay as 0 or become a 1? Stay as 0, and this is why you sometimes do have to put those zeros on the end. 7, 0. I have to put that 0 there because this is going to 2 sig figs. If I left that 0 off, that's incorrect. Okay? So, rule 1, never round off until everything is done. Rule 2, round off to the smallest number of sig figs represented in your original data. Okay? So there's the answers, but we wrote them up there. Example 1, 2, 3, and 4 are almost identical. I've just tweaked things slightly. Try these 4 on your own, looking at your neighbor. I'm going to freeze my screen, and then we'll see if we all get the same thing. So try these really quickly on your own. I've done the first 3. You can look up and see if you're doing them right. First one, 3 sig figs, yes, 75.4, I think. Second one, 2 sig figs, so I had to round to 75, rounding off properly. Third one, also 2 sig figs, so it rounded to 68. The fourth one, how many sig figs am I going to go to? 1. So I have, sitting on my calculator, 67.8. I guess I'm going to round off right to that 6. Is that 6 going to stay a 6? Except it's not a 7, it's a 70. Because look where that 6 is. And that's why that 0 is not considered significant. This is to 1 sig fig. If it was significant, Jackson, if it was to 2 sig figs, I would have showed that by putting a decimal there. No. So multiplying and dividing, which is the easier of the rounding off rules, you go to the smallest number of sig figs in your data. Is that okay? Turn the page. Adding, subtracting. Multiplying and dividing, I can almost always do the sig figs in my head and go straight to my calculator. Adding and subtracting, not always. Some of you may get to the point where you can, great. But for starters, here is my advice. If I'm adding and subtracting, I always rewrite the questions vertically lining up the decimal points. I did this one already for you. If I was adding 4.567 plus 9.0, I would write them vertically, and can you see I lined up the decimal? Rule 1 is the same. Don't round off until you're done. So type that into your calculator, please. 4.567 plus 9.0. And right now, I get 13.567. I'm going to write that down, keeping the decimal lined up. The rule, Erica, for adding and subtracting has nothing to do with how many sig figs is in your original data. Instead, here's what you do. Do I know both of those numbers in that column? Say yes. Do I know both of those numbers in that column? Do I know both of those numbers in that column? Then I'm going to round to this column. And you notice I haven't said the phrase sig figs. I've said column, which is why we write them vertically. So I'm going to round to that 5. But is that 5 going to stay a 5 or become a 6? So final answer, 13.6. By the way, how many sig figs does 13.6 have? 3. And you'll notice no 3 sig figs anywhere here. It's 4 sig figs and 2 sig figs. It's not to do with sig figs when you're adding and subtracting. It's what columns do you have filled in? That's where you round off to the final column that you know everything. The last decimal place that everything has in common. Okay? So, right here, let's do another one. 13.568 plus 9.24 plus 8.651. 13.568 plus 9.24 plus, good yawn, 8.651. You were the one that challenged me last time to stay awake. I'll bring it on if I have to. Can you put your phone face down, kiddo? Because you're not that important. Thank you. Write them vertically, keeping the decimal points in line. Add them as is before you do any rounding off. Or if it was subtraction, subtract them as is before you do. The rule for adding and subtracting is the same. So, 13.568 plus 9.24 plus 8.651. I get 31.459. Is that what you get? Now I'm going to shorten one step, Kenzie. Last time we wrote this down, I'm just going to keep it on my calculator screen. Alrighty. Where's the column where I'm missing stuff? Last one. So I'm going to round to the second column. I don't know. I can't remember because I just cleared my calculator screen. I'm going to round right to there. Is the 5 going to stay a 5 or become a 6? And become a 6. 13.46. Final answer is going to be 13.46, which has 4 sig figs, which did appear in that number, but this was 3 sig figs, this was 5 sig figs. That's just a coincidence that 4 sig figs appeared. It's how many decimals that you know. Obscure, weird ones.
31, right?
31, because for some reason I flipped them. Thank you. Candy for you, because I made a mistake. I owe you a candy, Dario. I'll get one in a second. I never make mistakes. It's a Freudian slip. It's when you say one thing, but you mean another. Okay. Weird, strange ones. 12 plus 4.683. Write it vertically. Go to your calculator. What am I rounding off to here? Which column? No decimal places. You can see already here I'm missing stuff. So I'm going to round off to that column, which is going to be 17. If you wanted to, you could put a token decimal there because it's 2 sig figs no matter what, but in this case you don't need to. Courtney sort of has her hand up. I know what she's thinking. She's saying, Mr. Dueck, you said that if we got good, we could do these without rewriting them. You can. I'll show you. Okay. It says, homework, see next page when you practice, but you got some white space down here, yes? What if they don't give them to me vertically and I'm too lazy to rewrite them? 6.83 minus 5.2175 plus 8.9. Write that down horizontally without rewriting it vertically. 6.83 take away 5.2175 plus 8.9. If we were multiplying or dividing, we would go 3 sig figs, 5 sig figs, 2 sig figs. I'm going to go to 2 sig figs. Are we multiplying or dividing, Carlo? No. You ready? I did say you can do these up here though too. How many decimal places does this number have? How many decimal places does this number have? How many decimal places does this number have? I'm going to end up rounding to 1 decimal place, because that's where I'm going to start to round out numbers. So you can kind of see the vertical alignment, Antonio, in your head if you're a little bit clever. I'm still going to go to my calculator. Don't round anything off. So let's go to my calculator now. It's going to be 6.83 plus Mr. Dueck minus 5.2175 plus 8.9. I forgot the 5. I caught that. This is why I told you to get a good calculator, so you can do things like backspace and edit. So I get that, and looking at this, I'm going to round off on that 5, I think, the first decimal column. Is that 5 going to stay a 5 or become a 6? Stay a 5. So it is possible to do these by hand. Now, what did we learn last day? Scientific notation is great for sig figs, because when you have the number in scientific notation, you only write down the significant digits. It's really obvious how many sig figs there are. So for example, looking at number 4, how many sig figs are there? 4! It's really obvious in scientific notation. How many sig figs are there in number 18? 4! So how many sig figs? Oh, they all seem to be 4 because I apparently went scientific notation. Anyways, what's your homework? This. I did attach the answers on the very, very last page here as well. And you got lots of time to practice this, and also hand in any of the homework from last day. By the way, did anybody figure out what was special about the radioactive cat, the terrible riddle on the page? 18 half-lives? That's so funny.